In Chapter 7, really going to focus on ratios and proportions. We're going to use the idea of ratios and proportions and involved in scale models and in similar figures, but right now we're just starting off with the basics. So today what we're going to focus on is finding equivalent ratios to create a proportion. Make sure you write that target down on your notes. Remember, with the videos you can pause if you need more time. So what is a ratio? A ratio is a comparison of two quantities. So it's a comparison of two quantities. And it's using division. So when you see a fraction, that's a ratio. So you can write a ratio three different ways. You can write it as a fraction. You could write it as A over B. Or you could write it as the word, you could write it with the word 2, A to B. Or there's a little symbol to represent this 2, and it's the little colon. So A to B can also be written that way. So there's three different ways you can write a ratio. Make sure you write down all three on your notes so that you have them. So, an example of the ratio, let's look at these pictures here. What is the ratio of number of coins to number of dollar bills? When you hit that word 2, that's a good sign of where your division bar is going to be or where this colon is going to be. So what were we talking about before the 2? We were talking about the number of coins. And what are we talking about after the 2? We're talking about the number of dollar bills. How many coins do you see? 1, 2, 3, 4, 5, 6, 7. So 7 coins. 2, how many dollar bills do you see? 1, 2, 3, 4, 5. This is a ratio. Now you could write that as 7 over 5. You could also write that as 7 to 5. We can also write it with the word 2. Now the order does matter. If you look at the next one, what is the ratio of dollar bills to the number of coins? Circle that word 2. What are you talking about before the 2? Well, we're talking about the number of dollar bills. And what are we talking about after the 2? We're talking about the coins. That word 2 is your division bar. That's what's splitting it. So whatever was before it is your numerator. How many dollar bills do I have? We said 5. And whatever comes after it is your denominator. How many coins do I have? 7. You can write it all three ways. Oops, I messed that one up. All right, try the last one. I'm talking about the value of the coins here now. What is the ratio of the value of the quarters to the total amount of money shown? Try that one. You can pause and then press play whenever you're ready. So the value of the quarters, well, how much are those quarters worth? Well, there's 7 quarters, and each quarter is worth 25 cents. So I do 7 times the decimal point 0.25, which means right now I have $1.75 in quarters, right? Then I hit that word 2, and I'm talking about the total amount of money shown. Well, how am I going to find the total amount of money shown? You're going to have to add the dollars and the quarters together, but it's not just the amount. So we have 5 $1 bills, plus we have 7 quarters. 5 plus $1.75 is going to be $6.75. So your ratio would be 175 to 675. Typically in a ratio, we don't really need to show the units. It would just be the numbers, okay? So $1.75 to $6.75. So we're going to talk about equivalent ratios today. And equivalent ratios means that they are equal. They may look different, but they have the same value in the end. Now your picture may not have printed with the colors, so you may want to shade these in. But when I look at 3/4 of the box, that is the same amount that's shaded as if I broke it in half again. I broke all of these into smaller boxes. And now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of the 16 total pieces. So the numbers look different, but the fraction is still equivalent. And I could break those boxes in half, each one of those. I could do all of those, and then I could count them all. With the same boxes being shaded as before, now that's really 48 out of the total of 64. All three of these ratios are equivalent because the same amount of the box is shaded. There's a couple easy ways to find equivalent ratios. As long as you multiply or divide both the numerator and the denominator by the same number, your new ratio will always be equivalent. So if I ask you to find two ratios that are equal or equivalent to the given ratio, multiply by a number, and you can divide by a number. Now you can choose whatever number you want to multiply and divide by, but I would keep it easy. I wouldn't go multiplying by 25 or 32 because that's going to be a little more work. What's the easiest number that you can multiply by? Well, we can't do 1 because that would be the same fraction, so how about 2? Okay, 9/27 times 2. Multiply both the numerator and the denominator by 2, and this will result in an equivalent fraction. Try it. 9 times 2 is 18. 27 times 2 is going to be 54. Well, your result is an equivalent fraction, so 18/54 is equal to 9/27. We could check it if we wanted by reducing it. You don't have to show this work here, but if I get back down to 9/27, how would I get there? Well, I would divide by 2, and I would divide by 2. So since that gets me down to the simplified fraction that's the same, I know those are equal. All right, let's try dividing by something. Make sure, you don't always have to do the division. You know, sometimes some fractions aren't evenly divisible by something, but I can simplify 9/27. What can I take out of there? I could take out 3. So let's divide both the numerator and the denominator by the same number. I'm going to divide by 3 because I know 3 will work. 9 divided by 3 is 3. 27 divided by 3 is 9. So find two ratios that are equal, 18/54 and 3/9. Now you may have taken out another 3. Here's another equal ratio because I could simplify this farther. You only needed 2, but I'm going to give you another one. 3 divided by 3 is 1. 9 divided by 3 is 3. So all 3 of these ratios are equivalent to this 9/27. Well, ratios that are equivalent are said to be proportional. There's a word for that. It's called proportional, although I'm misspelling it. It's called a proportion. Two ratios that are equal, it's called a proportion. So if you had 9/27 equal to 1/3, those make a proportion, okay? It's just one fraction equal to another fraction. That's all it is. Well, to tell whether two ratios are proportional, you have two options, okay? You could either simplify both the fractions down and see if they get down to the same simplified fraction, or you could find a common denominator, get the fractions to have the same denominator, and then see if the fractions match. So let's try both of these. I'm going to do the first problem using the simplified method. Do it with me. So 12/15, what can we simplify that fraction down to? Well, we can take out a 3 from both the numerator and the denominator, and that's going to leave me with 4/5. Let's try simplifying 27/36. You don't have to simplify it by 3. It can be by any number, but we're hoping it's going to get down to 4/5. Well, 3 does work, so let's use it. Okay. 27 divided by 3 is 9. 36 divided by 3 is 12. Well, those don't match, but wait a second. Is 9/12 fully simplified? It's not. What else can you take out of there? You can take out a 3 again. So make sure you keep going until you can't simplify any farther. 9 divided by 3 is 3. 12 divided by 3 is 4. 3/4, can I simplify that any farther? No. So looking at your end fractions here, looking at these two, are these two fractions proportional? Are they equivalent ratios? They are not. So no, they are not proportional. Let's try the second one using a different method. So I want you to try both of them on these notes. In your practice, try them both on your homework, please. You don't have to do, all the problems one way. Try them both. Another method you can use is you can find a common denominator. So when I see 1/5 and I see 6/30, what could I get both of those denominators to become? Well, I know I can get 5 to become 30. And 5 times what would give me 30? Times 6. So take that first fraction. I can't just multiply the bottom by 6. I have to do it to the top as well. Whatever you do on the numerator, you do to the denominator. And that's going to get me 6/30. So that was 1/5. And my other fraction is 6/30. Are these ratios equal then? Yes. 1/5 is equal to 6/30. So yes, these two are proportional. Okay, last two questions here. One's from the book, and one's a little bit of a preview to the next lesson, to 7-4. Try the book one about the computers on your own, and then press play to go over it with me. So when you read number 30, we're talking about a photo downloading, and it says it shows 42 kilobytes after 7 seconds. That's going to be your ratio because remember we're comparing two quantities. We're comparing the 42 kilobytes to 7 seconds. Well, I want to know, is the file downloading at about 6 kilobytes per second, which means that's like a per 1 second. So what am I asking? Really, I'm asking, are these equal? So you tell me, are they equal? Yes, because when you divide, I divided, you don't have to divide, but I divided and I got this to be equal to 6/1. So that is at a rate of 6/1. Or you could multiply this by 7 and get it to be 42/7, which is what you had here. So these are equal. Is the file downloading at 6 kilobytes per second? Yes, because we have to explain. So if you didn't write your explanation, write it down. Because these ratios are equivalent. So that's all you have to check. Were these ratios equivalent? All right, so a little preview into 7-4. The ratio of the number of bones in the human skull to the number of bones in the ears is 11:3. There are 22 bones in the skull. How many bones are in the ears? Remember that word two. I like that word. I'm going to circle it. So what am I talking about before? I have the human skull, 2, the bones in the ear. And I know that that is, so skull to ear, remember that's a ratio, and that's equal to 11/3. Skull to ear, keep the order. Well, there are 22 bones in the skull, so my skull is going to actually have 22 bones, and I want to know how many are in the ears. This is a proportion where we don't know one of the values. Both quantities on top talk about the skull. Both quantities on the bottom talk about the ear. How can you figure out what X is? Well, some of you may know cross products already. If you do, hold on to that because I want you to only use that if you understand why it works. But something you can do here is think about 11/3 is the reduced form of 22. So what would you divide 22 by to get 11? You would divide it by 2. Or let's go this way. What would you multiply by to get 22? You would multiply it times 2. Well, whatever you do to the top, you must do to the bottom. So what is X going to be? X is going to be 6. I hope you're seeing that. This is just an extension, so if you're not, that is okay. And that represented the bones in the ear. So this is just a preview, guys, to 7-4. All right, great work.